Hello everyone! Yellowstone National Park in Wyoming, known for witnessing the most powerful volcanic event in human history, has just shaken the earth once again. Known as a geological marvel that continuously captivates tourists and hikers with its breathtaking scenery, vibrant ecosystems, and unique geothermal features, Yellowstone holds far more secrets than we might imagine. However, hidden beneath the beauty of this iconic park lies an unbelievable and extremely disturbing phenomenon that has kept park officials and local residents on high alert. In a recent turn of events, this potential threat may have triggered a series of alarming incidents that sent shockwaves across the nation and led to immediate evacuations. What could have driven officials and residents to flee Yellowstone Park? Could the very forces that shape this terrain now spell its doom? Stay tuned until the end of this video to uncover the truth. A beautiful landscape Yellowstone National Park, the two stands as America's first national park and is often considered the world's first. Spanning 3,472 square miles across Wyoming, Montana, and Idaho, you would be surprised to find out that this picturesque landscape sits atop a massive magma chamber responsible for fueling the geothermal features that draw millions of visitors each year. Geologically, Yellowstone sits atop a volcanic and seismic hotspot known as a supervolcano, causing significant volcanic and seismic activity over millions of years. The region's crust has been thinned by tectonic movements, creating a dome of magma near the surface. About 2.1 million years ago, this magma dome erupted in one of the planet's most catastrophic volcanic events, releasing 600 cubic miles of rock and ash, much more than the 1980 Mount St. Helens eruption. Further eruptions occurred approximately 1.3 million and 640,000 years ago. Scientist Jake Lowenstern is looking for a pattern connecting the supervolcano today and its three prior major eruptions, 2.1 million years ago, 1.3 million years ago, and 640,000 years ago, forming the current Yellowstone caldera, a whopping 30 by 45 mile basin in the park's west-central area. The caldera itself is a result of several massive eruptions that occurred millions of years ago. These eruptions emptied the magma chamber below, causing the ground to collapse and form the caldera. This vast depression is filled with a variety of geothermal features, making Yellowstone a geological wonderland. The park is also a seismic hotspot, as it is a volcanic hotspot, with hundreds of minor earthquakes each year due to its underlying network of faults. These quakes typically go unnoticed, though significant ones occasionally impact the region. Yellowstone's natural wonders and dynamic geological landscape continue to lure visitors and scientists alike to come experience the fascinating and complex geological structure of Yellowstone. However, in recent months, something unusual has forced park officials, visitors, and surrounding residents into a mass exodus from the surrounding areas of Yellowstone. While Yellowstone has also experienced an unusual increase in earthquake activity, the cause for this exodus is beyond the recent earthquake swarms. In order to fully grasp the cause of the unusual event and its consequences, it is important to paint a clear picture of the possible potential threats posed by Yellowstone. Treading on hot, shaky grounds. It is important to note that in recent months, the Yellowstone Park has experienced an increased level of seismic activity. These succession of consistent quakes, although sometimes unnoticed, are called earthquake swarms. These swarms consist of hundreds of small quakes occurring over a short period. While not uncommon in volcanic regions, the intensity and frequency of the current swarm have raised concerns. Unlike a single large earthquake followed by aftershocks, an earthquake swarm involves many smaller tremors occurring close together in time and space. Though individually these quakes may not cause significant damage, their sheer number can be alarming. Earthquake swarms are clusters of seismic activity that can last for days, weeks, or even months. They are often associated with volcanic activity, as the movement of magma beneath the Earth's surface can cause the surrounding rock to fracture. This fracturing leads to a series of small earthquakes, which can be an indicator of magma movement. Yellowstone National Park has a history of earthquake swarms. The USGS is reporting 700 earthquakes hit there in the past 24 hours. some felt in San Diego. It's what they call an earthquake swarm. One of the most significant swarms occurred in 1985, with over 3,000 earthquakes recorded in just a few months. Surprisingly, this event, closely monitored by scientists, did not lead to a volcanic eruption, but contributed to our understanding of Yellowstone's volcanic activity. Each year, Yellowstone experiences between 1,000 and 3,000 earthquakes. Most are minor and go unnoticed, but some, like the 1959 quake, leave a lasting mark. Yellowstone's seismic activity is a result of its location within the Intermountain Seismic Belt and its status as an active volcano. This combination of tectonic and volcanic forces leads to frequent earthquakes, which play a crucial role in maintaining the park's famous geysers and hot springs by keeping their underground channels open. One of the most significant and tragic events in Yellowstone's seismic history occurred on the night of August 17, 1959. That night, a 7.5 magnitude earthquake struck near Hebgen Lake, just west of Yellowstone. The quake caused catastrophic damage, triggering a massive landslide that engulfed a campground and formed what is now known as Quake Lake. Amidst the chaos, 28 people lost their lives, with 19 still buried beneath the landslide debris. Survivors described the night as one of terror and confusion, with families scrambling to escape the rising waters and falling rocks. In response to the recent swarm, officials have increased monitoring and data collection. Scientists are using sophisticated technology, including seismographs and GPS stations, to track these earthquakes in real time. This helps them understand the activities beneath the surface and assess the risk of a potential volcanic eruption. For visitors and residents, this swarm serves as a stark reminder of Yellowstone's dynamic and unpredictable nature. Seismographs are sensitive instruments that detect and record ground movements caused by seismic waves. They can pick up even the slightest tremors, providing valuable data on earthquake activity. GPS stations, on the other hand, measure tiny movements in the Earth's crust. These stations are strategically placed around Yellowstone to monitor changes in the ground surface, which can indicate magma movement or other geological activity. The data collected by seismographs and GPS stations is analyzed in real time by scientists at the United States Geological Survey, USGS, and the Yellowstone Volcano Observatory, YVO. This continuous monitoring allows researchers to detect patterns in the seismic activity and assess the potential for more significant volcanic events. By understanding the underlying causes of these earthquakes, scientists can better predict future activity and prepare for any possible scenarios. When discussing the potential risks associated with increased seismic activity at Yellowstone, the possibility of a volcanic eruption is most concerning. Although the chances of an imminent eruption are low, it's a possibility that cannot be entirely dismissed. Supervolcanoes can produce eruptions thousands of times larger than typical volcanoes. 640,000 years ago, a supervolcano erupted, killing millions of prehistoric creatures roaming the ancient landscape. What if an even bigger explosion, a volcanic hypereruption? The last major eruption at Yellowstone occurred about 640,000 years ago, leaving a massive caldera. If Yellowstone were to erupt again, it could release a tremendous amount of ash and gases into the atmosphere, leading to significant consequences. A supervolcano eruption would have catastrophic effects on a global scale. The massive release of ash and gases could block sunlight, leading to a drop in global temperatures. This phenomenon, known as a volcanic winter, could last for years and disrupt weather patterns, agriculture, and ecosystems worldwide. The ashfall would also affect a vast area, potentially covering much of the continental United States. This could disrupt air travel, contaminate water supplies, and damage crops, leading to food shortages. The fine particles in volcanic ash pose serious health risks, particularly respiratory problems. Inhalation of these particles can cause lung damage and exacerbate existing respiratory conditions. Ashfall can also contaminate water sources, making it unsafe for consumption. The long-term exposure to volcanic ash could have severe health implications for affected populations. The Yellowstone Volcano Observatory employs the use of seismographs and GPS stations to monitor geological patterns and fluctuations in the region. Seismographs are sensitive instruments that detect and record ground movements caused by seismic waves. They can pick up even the slightest tremors, providing valuable data on earthquake activity. GPS stations, on the other hand, measure tiny movements in the Earth's crust. These stations are strategically placed around Yellowstone to monitor changes in the ground surface, which can indicate magma movement or other geological activity. The data collected by seismographs and GPS stations is analyzed in real time by scientists at the United States Geological Survey and the Yellowstone Volcano Observatory. This continuous monitoring allows researchers to detect patterns in the seismic activity and assess the potential for more significant volcanic events. By understanding the underlying causes of these earthquakes, scientists can better predict future activity and prepare for any possible scenarios. The Yellowstone Volcano Observatory continuously monitors this region, providing invaluable data on its volcanic activity. In May 2024, the caldera remained at background levels, experiencing 62 minor earthquakes, the largest being a mere magnitude 1.8. These tremors, including an ongoing minor swarm north of West Yellowstone, Montana, are typical for this region, contributing to about half of Yellowstone's seismicity. Ground deformation studies indicated ongoing subsidence of the caldera, a phenomenon observed since 2015, with seasonal shifts causing slight uplift during summer. The caldera has subsided by approximately 3 centimeters since September, with Norris Geyser Basin seeing about 1 centimeter of subsidence in recent months. The dynamic nature of Yellowstone's geothermal features was highlighted by the eruption of Steamboat Geyser on May 30th, marking its third significant water eruption of the year. The world's tallest active geyser just set a record. Steamboat Geyser in Yellowstone National Park erupted for the 30th time this year. In a collaborative effort to enhance monitoring and research, YVO consortium members gathered at Mammoth Hot Springs, engaging in fieldwork, maintaining GPS and borehole stations, and deploying temporary GPS sites to bolster the existing network. The dynamic nature of Yellowstone's geothermal features means they are constantly changing, and an increased seismic activity can lead to significant alterations in these features, making them unpredictable. For example, geysers like Old Faithful might become more or less active due to shifts in pressure and heat. New hot springs might appear, and existing ones could change in temperature, flow rate, and chemical composition, impacting both their appearance and behavior. However, this unpredictability adds to the park's allure, drawing scientists and tourists alike to witness the ever-changing landscape. However, it also means that visitors must be cautious and aware of potential hazards for the safety of visitors. Visitors are advised to stay on marked trails and follow all safety guidelines to avoid accidents. It is imperative to note that Yellowstone is home to a diverse range of wildlife, including bison, elk, wolves, and grizzly bears. These animals have adapted to the park's dynamic environment over millennia, developing strategies to cope with natural disturbances such as seismic activity and volcanic eruptions. While the dynamism of Yellowstone National Park created the complex and noteworthy ecosystem, this feature can also mar its beauty as increased seismic and volcanic activity can disrupt wildlife habitats, causing landslides or altering the terrain. This can affect the availability of food and shelter for animals, forcing them to move to new areas in search of resources. Animals that rely on specific geothermal areas for warmth or food might find those areas altered or destroyed by seismic activity. Volcanic eruptions pose an even more significant threat, as ashfall can smother vegetation and contaminate water sources. Despite these challenges posed by the park, many species in Yellowstone have demonstrated remarkable resilience. Bisons, for example, are generalists that can graze on a variety of grasses and plants. Their herds move across large areas following the seasonal availability of food and water. This flexibility allows them to adjust their movements in response to changes in their habitat caused by seismic activity. Grizzly bears and wolves, on the other hand, have more specialized needs. Grizzlies rely on a diet that includes berries, nuts, and meat from large prey animals. Changes in vegetation or disruptions to their food sources can impact their ability to find enough food to survive and reproduce. Wolves, as top predators, help regulate prey populations like elk and deer. If seismic activity alters the landscape or changes prey distribution, wolves may need to adjust their hunting strategies or territories. Scientists and park officials closely monitor the impact of seismic activity on wildlife. They study animal behavior, track population trends, and use GPS collars to monitor movements. This research helps understand how different species respond to environmental changes and identify potential risks. Efforts to protect wildlife include maintaining connectivity between different parts of the park, allowing animals to migrate safely even if their usual habitats are disrupted. One of the key strategies for protecting wildlife is the creation of wildlife corridors. These corridors connect different habitats within the park, allowing animals to move freely between them. This is especially important during periods of increased seismic activity, when animals may need to relocate to find food, water, or shelter. Maintaining these corridors helps ensure the long-term health and genetic diversity of Yellowstone's wildlife populations. Local residents living near Yellowstone provide unique insights into the recent seismic activity. For people who live in the surrounding areas of the park, these tremors aren't just headlines. They're part of living in a place where the earth beneath their feet is alive. They constantly experience a mix of familiarity and caution when it comes to the earthquake swarm. The local community has a deep connection to Yellowstone and its natural wonders. They are accustomed to living with the park's dynamic environment. Despite occasional concerns, they express confidence in the park officials and scientists who monitor these events closely. This reassurance comes from understanding the ongoing monitoring efforts and trusting in the expertise behind them. Living near Yellowstone means being prepared for the unexpected. Local residents take various precautions to ensure their safety, such as having emergency plans in place and staying informed about the latest developments. They rely on the continuous monitoring and transparent communication from park officials and scientists to stay updated on any potential risks. In conclusion, the recent earthquake swarm at Yellowstone underscores the importance of vigilant monitoring and preparedness. While the chances of a major volcanic eruption are low, the potential consequences are significant. Advanced technology and continuous data analysis help scientists understand and predict seismic activity, ensuring that appropriate measures are taken to protect both the park and its visitors. Despite the possibilities of any imminent geological catastrophes, the shocking event that led to the mass evacuation of more than 1,000 people from Yellowstone and its vicinity was unprecedented and had scientists and the public puzzled. The historic Yellowstone flood. A statewide disaster has been declared in Montana in the wake of unprecedented flooding in Yellowstone National Park this week. Recently, Yellowstone National Park faced a historic summer flood that caused significant damage, washing out roads and closing several park entrances just before the peak tourist season. This wasn't the first time the park experienced such devastation. A similar occurrence, but with lesser consequences, took place in 2004. A sudden evening thunderstorm led to a massive mudslide that buried several vehicles and trapped people inside, creating a life-threatening situation. The 2004 disaster began when a thunderstorm unleashed rain and hail, causing the mountainside to collapse onto the roadway just 7 miles inside Yellowstone's East Gate. Mud and boulders engulfed at least 3 vehicles near a steep drop-off, trapping the occupants. Rescue efforts began minutes later, with park rangers and volunteers arriving to help 16 victims. Due to the mud and debris trapping the vehicle doors shut, rescuers had to pull people out through the windows. The clearing operations commenced quickly, but progressed slowly because of the hazard posed by leftover avalanche control shells. For 30 years, the park had used cannons to prevent avalanches, leaving unexploded duds that rescuers had to carefully navigate using metal detectors. Despite these challenges, the road was reopened within days. However, in contrast, the recent flood resulted in prolonged closures of the park's north and northeast entrances, lasting all summer. Initial reports attributed the flood to a sudden heat wave, but Chief Meteorologist Ed McIntosh clarified that rain, not sun, was the primary catalyst. Over several days in June, 3 to 5 inches of rainfall melted the snow, equating to 6 to 8 inches of water filling the rivers, streams, and creeks in a single day. The flood, triggered by a combination of heavy rainfall and rapid snowmelt, wreaked havoc on the park's landscape, infrastructure, and ecosystems. As the torrential rains began, the park's rivers and streams swelled beyond their capacities, turning into raging torrents that carved new paths through the terrain. The Yellowstone River, in particular, surged with unprecedented force, its waters breaking through banks and sweeping away everything in their path. Roads and bridges that had stood for decades were no match for the floodwaters, which left behind a trail of destruction. Sections of the park were rendered inaccessible and vital infrastructure was severely damaged, cutting off communication and transportation routes. The human impact of the flood was profound. Visitors and park staff alike found themselves in precarious situations, with some having to be evacuated swiftly to ensure their safety. The park's emergency response teams were mobilized, working tirelessly to coordinate rescues and provide aid to those affected. Despite the challenging conditions, the spirit of cooperation and determination among the responders and the community was palpable. Ecologically, the flood posed significant challenges. Yellowstone's diverse wildlife, from its iconic bison and elk to its lesser-known species, faced immediate threats. Habitats were disrupted and food sources were washed away, forcing animals to adapt quickly or relocate to safer areas. The park's renowned geothermal features, such as geysers and hot springs, also experienced changes, with some areas becoming more volatile due to the shifting underground water pressures. In the wake of the flood, the park's management initiated a comprehensive assessment of the damage. Engineers and environmental scientists worked together to evaluate the extent of the destruction and plan the necessary repairs and restoration efforts. This included not only rebuilding infrastructure, but also ensuring that the ecological balance of the park was maintained. Public support played a crucial role in the recovery process. Donations and volunteer efforts poured in from across the country, reflecting the deep connection many people feel to Yellowstone. Conservation groups and governmental agencies collaborated to provide resources and expertise, ensuring that the restoration efforts were both effective and sustainable. As the waters receded, the scars left by the flood began to heal. Roads and bridges were rebuilt, often with improved designs to withstand future natural events. Wildlife slowly returned to their habitats, aided by the park's conservation initiatives. The flood, while a tragic event, also served as a reminder of the importance of preserving and protecting natural spaces. The floods, therefore, were a result of rain-soaked snowmelt. Similarly, the 2004 mudslide was linked to environmental factors, specifically a wildfire from the previous year. The fire destroyed 17 miles of forest within Yellowstone's east entrance, removing vegetation that had stabilized the ground. This loss of vegetation set the stage for the mudslide when heavy rains came. These events underscore the unpredictability and uncontrollable nature of Yellowstone's environment. The park's dynamic and sometimes dangerous conditions remind us of the powerful forces of nature at play and the resilience required to navigate such natural disasters. Educating the public about Yellowstone's geological activity is crucial for ensuring safety and fostering a deeper appreciation for the park's unique environment. Public education programs, guided tours, and informational materials can help visitors understand the importance of respecting and protecting the park's geothermal features and wildlife. Increased awareness will also encourage responsible behavior, such as staying on marked trails and following safety guidelines. Yellowstone National Park is a place of unparalleled natural beauty and geological significance. The recent earthquake swarm serves as a reminder of the dynamic forces at work beneath the surface. By continuing to monitor and study these events, scientists can better understand the complex interactions that shape this incredible landscape. Through vigilance, collaboration, and public education, we can ensure that Yellowstone remains a treasured destination for generations to come. We have come to the end of this video. You can support us with the Super Thanks button below. Please do not forget to subscribe to our channel and turn on notifications in order to be informed about new videos. Our contents are carefully prepared by our expert team. Thank you for watching us.